The potential atmospheric conditions enveloping the rocky exoplanet are being considered. Greetings, everyone. In today's video, we will delve into the fascinating subject of researchers utilizing NASA's James Webb Space Telescope to gain a deeper understanding of the atmosphere surrounding the rocky exoplanet 55 Cancri E. Despite its close proximity to its star and extreme heat, this planet is believed to possess an atmosphere abundant in volatile substances, as evidenced by infrared measurements. This discovery not only provides valuable insights into the distinctive features of 55 Cancri E, but also offers potential clues about the early conditions of other rocky planets such as Earth, Venus, and Mars. So without any further delay, let us embark on our enlightening discussion. Lead author Renyu Hu, affiliated with NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, recently published a paper in Nature. In this publication, Hu emphasizes the groundbreaking impact of the Webb telescope on the study of exoplanets, particularly rocky ones. Hu describes Webb as a catalyst for a novel scientific approach, expanding the boundaries of exoplanet characterization. Janssen, or 55 Cancri E, is a celestial body located in the Cancer constellation that orbits around the star 55 Cancri E, which closely resembles our Sun. This planet, classified as a super-Earth due to its size, has a diameter approximately double that of Earth and a slightly higher density. Its composition is expected to be comparable to the rocky planets within our own solar system, making it larger than Earth but smaller than Neptune. Characterizing 55 Cancri E as merely rocky would be misleading, as the planet's proximity to its star, approximately 1.4 million miles or 1/25th the distance between Mercury and the Sun, suggests a surface that is most likely molten, resembling a seething sea of magma. Additionally, due to its close orbit, it is probable that the planet is tidally locked, meaning that one side perpetually faces the star, while the other side remains shrouded in eternal darkness. Despite multiple observations made since its discovery of transiting in 2011, the inquiry into whether or not 55 Cancri E possesses an atmosphere remains unresolved, primarily due to the challenges posed by its extreme temperature, relentless stellar radiation, and wind emanating from its star. After spending over 10 years dedicated to this planet, Diana Dragomir, a researcher specializing in exoplanets at the University of New Mexico and co-author of the study, expressed her frustration with the lack of conclusive findings from previous observations. However, she now finds herself filled with excitement as the long-awaited answers begin to emerge. While the atmospheres of gas giant planets have been relatively easy to detect for over 2 decades, the search for thinner and denser atmospheres surrounding rocky planets has proven to be more challenging and elusive. Based on previous research utilizing data from NASA's retired Spitzer Space Telescope, it was suggested that 55 Cancri E possesses a significant atmosphere abundant in volatile substances such as oxygen, nitrogen, and carbon dioxide. However, there was also the possibility that the planet is devoid of an atmosphere, and instead covered by a thin layer of vaporized rock containing elements like silicon, iron, aluminum, and calcium. Due to the extreme heat, some of the molten rock would vaporize, explained Hu. To distinguish between these two possibilities, the team utilized Webb's NIRCam and MIRI to analyze the infrared light, specifically in the 4 to 12 micron range emitted by the planet. While Webb is unable to directly capture an image of 55 Cancri E, it has the capability to detect and analyze subtle variations in light emitted by the star system during the planet's orbital movement. Through the subtraction of the brightness observed during the secondary eclipse, specifically when the planet is positioned behind the star, from the brightness observed when the planet is adjacent to the star, the research team successfully determined the quantity of infrared light at different wavelengths emanating from the planet's day side. To explore the possibility of an atmosphere on 55 Cancri E, scientists have employed a technique called secondary eclipse spectroscopy, which is also utilized in the study of atmospheres on other rocky exoplanets like TRAPPIST-1b. The initial hint of a substantial atmosphere on this planet was derived from temperature measurements based on its thermal emission. By analyzing the heat energy emitted in the form of infrared light, researchers were able to make observations. If the planet is predominantly covered in dark, molten rock, with either a thin layer of vaporized rock or no atmosphere at all, the dayside temperature would reach an astonishing 4,000 degrees Fahrenheit, approximately 2,200 degrees Celsius. According to WHO, the MIRI data revealed a rather modest temperature of approximately 2,800 degrees Fahrenheit, 1,540 degrees Celsius. This finding strongly suggests that there is a transfer of energy occurring from the day side to the night side, most probably facilitated by an atmosphere abundant in volatile substances. Although lava currents can transport some heat to the night side, they are not capable of efficiently producing the observed cooling effect. Upon analyzing the data collected by the NIRCam, the team observed patterns that align with the presence of an atmosphere abundant in volatile substances. Co-author Arun Bello-Aruf, hailing from NASA JPL, elaborated on this discovery, stating, "Within the spectrum, we detected a decline in light intensity between 4 and 5 microns, indicating a reduced transmission to the telescope. This strongly suggests the existence of an atmosphere containing either carbon monoxide or carbon dioxide, as these gases absorb light within these wavelengths." It is important to note that a planet lacking an atmosphere or possessing an atmosphere solely composed of vaporized rock would not exhibit this distinctive spectral characteristic. After dedicating the past decade to modeling various scenarios and envisioning the potential appearance of this world, it is truly invaluable to receive some validation for our efforts, expressed Yamila Miguel, a co-author from the Leiden Observatory and the Netherlands Institute for Space Research, SRON. The team postulates that the gases enveloping 55 Cancri E originate from its interior rather than being present since its formation. Due to the scorching temperatures and intense radiation emitted by the star, the primary atmosphere would have dissipated long ago, explained Bello-Aruf. Instead, this is a secondary atmosphere that is constantly replenished by the magma ocean. Magma is not solely composed of crystals and liquid rock. It also contains a significant amount of dissolved gas. Although 55 Cancri E is not suitable for sustaining life due to its extreme heat, scientists believe that it presents a valuable opportunity to examine the dynamic relationships between atmospheres, surfaces, and interiors of rocky planets. By studying this planet, researchers hope to gain insights into the early environments of Earth, Venus, and Mars, which were believed to have been engulfed in molten oceans in ancient times. Our ultimate goal is to comprehend the specific conditions that enable a rocky planet to maintain an atmosphere rich in gases, which is crucial for supporting habitability, explained WHO. As part of Webb's General Observers (GEO) program in 1952, this research was carried out. Currently, there is ongoing analysis of supplementary observations of the secondary eclipse of 55 Cancri E. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.